In the middle of the 20th century, few things in America rivaled the sheer scale and influence of the Bethlehem Steel plant. Here, mile-long furnaces and towering stacks forged the steel that shaped the nation's bridges, warships, and skyscrapers. This was industry at its most ambitious, an enterprise so vast it seemed immovable, essential to how modern America was built. But beneath this outward permanence, hidden vulnerabilities quietly multiplied as the decades passed. How did a company that powered an entire era allow structural pressures to accumulate until the furnaces fell silent? The answer begins long before anyone noticed the first cracks. Eugene Grace stood at the center of Bethlehem Steel's wartime expansion, steering the company toward an unprecedented build-out as World War II intensified. Under his leadership, the Bethlehem plant transformed into a vast industrial complex, its boundaries stretching with each new contract from Washington. Between 1941 and 1945, the facility added a series of new blast furnaces and coke ovens, each one built to fulfill the urgent demands of the United States Navy. Grace's correspondence with the War Production Board reveals a clear directive: expand capacity, deliver steel, and do it at a scale that matched the stakes of global conflict. The numbers tell the story. Furnace output at Bethlehem rose by nearly 50% during the war years. Construction crews worked around the clock, pouring concrete and laying rails for new lines that would feed the insatiable appetite of shipyards and armament factories. The plant's integrated model, raw materials in, finished steel out, became a template for wartime production across the country. At its peak, the Bethlehem plant supplied steel for more than 1,000 naval vessels, each one a testament to the scale of its operation. This expansion was not a matter of chance or passive response. Grace made deliberate choices, pushing for additional coke ovens and larger blast furnaces, even as some board members questioned the long-term need. The logic was simple: the war would not last forever, but the fixed assets built in those years would define the company's capacity for decades. The plant's physical footprint grew, and with it, the complexity of its operations. Rail lines snaked between new furnace bays, while warehouses and machine shops multiplied across the site. The drive for capacity brought short-term rewards, record production numbers, lucrative government contracts, and a reputation as the backbone of the American war effort. But it also locked Bethlehem Steel into a high-cost structure. Every new furnace and oven added to the plant's fixed obligations, making it increasingly difficult to adjust as market conditions changed. The same infrastructure that allowed for wartime dominance would, in time, become a source of rigidity. Grace's strategy reflected the priorities of the era: scale, speed, and the ability to deliver on a national promise. As the war ended and demand shifted, the immense asset base built for conflict would prove both a strength and a constraint, a legacy that shaped every choice the company faced in the decades that followed. Steel from Bethlehem shaped the American landscape in the decades after World War II. By the 1950s and the 1960s, the plant's output stood at the center of the nation's most ambitious infrastructure projects. Its mills produced the beams and girders that formed the backbone of skyscrapers in New York, Chicago, and San Francisco. The Golden Gate Bridge, the Chrysler Building, and Madison Square Garden all relied on Bethlehem's heavy structural steel. Railways stretching from coast to coast, massive dams, and the transcontinental highway system drew on the plant's steady supply of rolled sections and plate. The reach of Bethlehem Steel was not limited to civilian projects. The plant served as a principal supplier to the U.S. Navy, delivering armor plate and hull steel for aircraft carriers, battleships, and submarines. During the Cold War, contracts for military hardware and infrastructure poured in, ensuring that the furnaces rarely cooled. By 1960, Bethlehem's annual production surpassed 23 million tons, a figure that placed it second only to U.S. Steel nationally. Its workforce numbered in the tens of thousands, and the plant's physical footprint covered more than 1,000 acres along the Lehigh River. The company's integrated structure allowed it to control every stage of production, from raw ore and coke to finished beams and rails. Rail lines within the plant moved materials between blast furnaces, open hearth shops, and rolling mills in a tightly choreographed flow. This scale of operation enabled Bethlehem to fill orders for entire bridges or skyscrapers delivered on time and to exacting specifications. For decades, architects and engineers treated Bethlehem Steel as the default partner for projects that demanded strength, reliability, and volume. Financially, the post-war years brought record revenues. Lucrative contracts for highways, dams, and urban renewal projects kept the order books full. The plant's reputation for quality and capacity made it the preferred supplier for both government and private industry. Bethlehem's name became synonymous with progress and national ambition, a symbol of the country's ability to build big and build fast. Yet this dominance rested on a model that required constant high-volume output. The fixed costs of maintaining blast furnaces, coke ovens, and sprawling rail yards demanded a steady stream of large-scale projects. The company's leadership, shaped by decades of success, saw little reason to question the approach. The logic of scale, bigger furnaces, more capacity, larger contracts, guided every major decision. In these years, the plant's stature was unchallenged. Its steel ran through the veins of American infrastructure, its workforce powered the local economy, and its balance sheets reflected the confidence of an era. But beneath the surface, the same forces that had propelled Bethlehem to the top were beginning to shift. The story of dominance was already entangled with the pressures that would later test the company's resilience. If you value research-driven documentaries that go beyond surface-level history, consider subscribing. Your support makes it possible to produce more in-depth episodes on the forces that have shaped and reshaped American industry. The summer of 1959 brought operations at Bethlehem Steel to a grinding halt. For 116 days, the plant's gates remained locked as thousands of workers joined what would become the longest nationwide steel strike in American history. Inside union halls, negotiations stretched late into the night. The core dispute centered on not just wages, but the future terms of employment in an industry facing uncertain prospects. Union representatives pressed for a new kind of security, wage escalator clauses that would tie future pay increases directly to the consumer price index. Management, already wary of rising costs, recognized the magnitude of this shift, but ultimately conceded in order to restart production. When the strike ended in November, a new cost structure was in place. The wage escalators meant that every uptick in inflation would automatically raise the company's payroll. What had once been a predictable expense now became a moving target. Internal grievance records from the early 1960s show a steady stream of disputes over the application of these clauses, especially as productivity gains lagged behind the rising pay scale. For Bethlehem Steel, the immediate cost of the strike, estimated at $250 million in lost output, was only the beginning. The real impact would unfold gradually, as the plant's labor costs ratcheted upward year after year, eroding the margins that had once funded maintenance and modernization. The feedback loop was set. Higher labor costs left less room for capital investment, making it harder to upgrade aging equipment or adopt new production methods. Each contract negotiation layered new obligations onto an already heavy structure. In this environment, even modest inflation translated into permanent financial pressure. The plant's ability to adapt to global competition and technological change was quietly but decisively constrained. Management's faith in the old integrated model shaped every major investment at Bethlehem Steel, even as the world outside the plant gates changed. By the mid-1960s, outside consultants had quietly warned that the plant's reliance on open hearth furnaces and manual processes was unsustainable. A confidential study recommended a sweeping automation plan, replacing aging furnaces, installing continuous casting lines, and piloting a mini-mill for specialty products. The projected cost was staggering, $450 million over 5 years, with an 8-year payback through lower labor and energy costs. But when it came time to allocate capital, the board diverted most of the funds to patching up existing infrastructure. Only a fraction went toward true modernization. Meanwhile, foreign competitors were moving quickly. In Japan and Western Europe, new steel plants were built from the ground up with automation at their core. By the late 1970s, a typical overseas mill could produce a ton of steel with 30% less labor than Bethlehem. Continuous casting lines and agile mini-mills allowed these rivals to shift between products and respond to market changes with a speed that the sprawling Pennsylvania complex could not match. Bethlehem's leadership saw these advances firsthand. In 1978, executives toured Nippon Steel's facilities and returned with detailed reports on automated casting and flexible production lines. Yet the recommendations were set aside. The company's capital remained tied up in its vast, aging footprint. As foreign mini-mills expanded their reach, Bethlehem's productivity gap widened, leaving the plant exposed to price competition and shrinking demand for heavy structural steel. The chance to narrow the technology gap had come and gone, reinforcing the plant's vulnerability as new pressures gathered on the horizon. Federal environmental regulation arrived as a new kind of cost, one that could not be negotiated or deferred indefinitely. The Clean Air Act amendments of 1970 required the Bethlehem plant to install scrubbers and sulfur capture systems on its blast furnaces. Internal projections put the price tag at $150 million just to bring the main stacks into compliance. For a plant already straining under labor and maintenance expenses, this was a staggering figure. Management chose to delay the upgrades, relying on temporary exemptions that would expire in the early 1980s. The decision meant that every year the risk of forced shutdowns grew. By the late 1970s, the EPA began issuing compliance notices for excessive emissions. Each notice triggered a scramble among shift supervisors and maintenance crews. Production schedules were rewritten overnight. Some furnaces were idled for weeks at a time, breaking the continuous flow that had defined the plant's operation for generations. A foreman, whose career spanned both the boom years and the regulatory era, described the new reality in a company grievance report. He said they used to worry about keeping the iron hot. Now every shift starts with a check on the EPA's latest ruling. Sometimes you spend half your time waiting for word from the front office before you can even fire up the furnace. The cost of delay was not just measured in capital budgets. Each period of downtime meant missed delivery deadlines, lost contracts, and growing uncertainty on the shop floor. The plant's complex web of fixed costs, already stretched thin, became even more brittle. Compliance pressure was no longer a distant threat. It was a daily operational constraint, tightening with every new enforcement deadline. In early 1983, a delegation of Bethlehem Steel executives traveled overseas, tasked with studying the operations of leading foreign steelmakers. Their findings painted a stark picture. Modern plants in Japan and Western Europe operated with a level of automation and efficiency that far outpaced the aging integrated mills back home. Productivity studies revealed that these competitors could produce steel with significantly less labor thanks to continuous casting lines and flexible mini-mill layouts. The report circulated among board members warned that the gap was widening. Bethlehem's cost per ton was rising, while foreign producers were pulling further ahead each year. The board convened in March to weigh the evidence. The agenda was clear. Should Bethlehem commit capital to a new generation of mini-mills or double down on the existing integrated complex? Tensions ran high. On one side, proponents of the mini-mill argued that without a shift, the company would remain trapped in a cycle of high fixed costs and shrinking demand. They pointed to the delegation's report and earlier consulting studies projecting lower labor costs and greater throughput with mini-mill technology. On the other, defenders of the traditional model insisted that the integrated plant scale was essential for large infrastructure contracts and that abandoning it would mean writing off decades of investment. The decision came down to a vote. 7 directors sided with the status quo, citing the risks of diverting resources from core operations and the uncertainties of entering specialty steel markets. 5 directors supported the mini-mill proposal, urging action before the company's competitive position eroded further. The 7-5 result locked Bethlehem Steel into its existing path. No funds were allocated for mini-mill construction or major automation. The company would continue operating as it had, relying on its vast, labor-intensive plant, even as the industry's center of gravity shifted elsewhere. From that moment, the strategic door to meaningful adaptation quietly closed. The productivity gap with foreign competitors became a structural disadvantage, not a temporary setback. The board's choice, shaped by decades of precedent and a reluctance to abandon sunk investments, set the trajectory for the company's next decade, a slow unraveling, defined less by sudden shocks than by the steady accumulation of missed opportunities and mounting pressures. Order books that once ran deep into the future began to thin out. By the early 1990s, cancellations from longtime clients were no longer an exception, but the rule. Shipyards and bridge contractors, facing their own pressures, shifted to foreign suppliers or lighter materials. In the rolling mills, crews found themselves idling for hours between assignments. The plant's final steel pour took place on November 18, 1995. That morning, a handful of workers gathered as the last ladle tipped, sending a stream of molten metal into waiting molds. The silence that followed was not just the absence of machinery, but the end of a cycle that had defined the city for generations. The economic consequences rippled outward. Tax records show that Bethlehem's property tax base shrank by 40% within a few years of the shutdown. Municipal budgets, once buoyed by steady industrial revenue, were forced into retrenchment. Street repairs, social services, and public safety all felt the strain. Local businesses that had supplied everything from machine parts to lunches for shift workers closed their doors, 45 in total, between 1998 and 2002. The impact extended to families. Enrollment in the Bethlehem area school district dropped by 2,600 students as families left in search of work elsewhere. A community leader from South Bethlehem described the effect as a slow unraveling. The plant had anchored not just the economy, but the rhythms of daily life. Church picnics timed to shift changes, youth sports funded by union halls, neighborhoods built around the promise of steady wages. With the furnaces cold, these patterns fractured. What remained was a landscape of uncertainty, empty storefronts, shrinking classrooms, and a city government stretched thin. For viewers who value research-driven documentaries that go beyond surface-level history, consider subscribing. Your support helps make it possible to produce more episodes on the hidden forces shaping American industry. The shutdown of Bethlehem Steel's plant was not a single event, but a drawn-out process measured in lost contracts, shuttered businesses, and families moving away. The numbers tell a story of decline, but the deeper loss was the unraveling of a social and economic system that had once seemed permanent. Bethlehem's silent mills are more than relics. They are evidence of how entire systems can become brittle and unresponsive under new pressures. Today, automation, shifting global markets, and policy choices continue to reshape industries at scale. What happened here is not isolated. It is a blueprint for adaptation or obsolescence. If you value these deeper explorations, your support makes future episodes possible. Thank you for watching.